As telescopes like the James Webb peer into the depths of space, excitement grows around the discovery of exoplanets. Just over 3 decades ago, in 1992, we confirmed our first exoplanet. Since then, over 5,500 have been discovered, but that's just scratching the surface. The Milky Way, spanning 105,700 light-years, could harbor billions of undiscovered worlds. With the notion of an Earth 2.0 tantalizingly close, it's easy to get swept up in the hype. Today we'll take a critical tour of the exoplanets vying for the title of our new home, exploring what makes a planet truly habitable. When searching for an Earth 2.0, it's crucial to establish our non-negotiables. Temperature is a primary concern. The Goldilocks zone, the area around a star where conditions might allow liquid water, is essential. However, being in this zone doesn't guarantee habitability. For example, Venus is in the right position but is a scorching inferno due to its thick atmosphere. Atmosphere is another key factor. A habitable planet needs a breathable atmosphere, ideally with oxygen and water vapor and free of toxic elements. Now let's consider the neighbors, specifically the type of star. Our Sun is a stable G-type yellow dwarf, providing a consistent environment for life. However, yellow dwarfs make up only about 10% of stars. The majority are red dwarfs, which have much tighter Goldilocks zones due to their low luminosity. Red dwarfs can unleash powerful flares, 100 to 1,000 times more intense than our suns, potentially stripping away atmospheres and making life unsustainable. If you're thinking about living on a planet orbiting a red dwarf, you better stock up on sunscreen. Many planets around red dwarfs are tidally locked, meaning one side faces the star at all times. This creates a permanent day on one side and eternal night on the other, leading to extreme conditions that make survival difficult. Plus, these planets likely have weak magnetic fields, exposing them to harmful cosmic radiation. Take Proxima Centauri b, for example. While it's Earth-sized and sits in the habitable zone of the closest star to us, it faces numerous challenges due to its red dwarf host. Despite its rocky surface, the intense radiation and potential tidal locking may render it inhospitable. Then there's Kepler 186f, another candidate once thought to be promising. This Earth-sized exoplanet orbits a red dwarf as well, putting it at risk of harmful stellar flares and extreme conditions that could make survival challenging. In contrast, Kepler 452b often earns the title of Earth's twin. It orbits a yellow dwarf like our Sun and sits in the Goldilocks zone, where liquid water could exist. However, it's classified as a super-Earth, meaning its gravity is about twice that of ours. This raises questions about how humans might cope with such increased pressure. The hunt for Earth 2.0 continues, but finding a planet that meets our criteria for habitability is no small task. The odds suggest there may be billions of undiscovered planets out there, but we can't know their true potential until we can visit them. So, if someone claims to have found our perfect new home, take it with a grain of salt. We won't truly know if a planet can support life until we can explore it firsthand. As we gaze at the stars, let's embrace the thrill of discovery and the patience required in our quest for knowledge. Thank you for joining me on this exploration of exoplanets. For more insights, check out my other videos, and don't forget to subscribe for the latest updates from the cosmos. Until next time, keep dreaming big.